Hmm. Great. Let there be light! So our idea was to produce electricity using a water wheel. So we went out and we created our own water wheel and our own generator. Our water wheel is made out of 2 CDs with some styrofoam in the middle, but it's not as simple as it looks. We had to angle each piece of styrofoam specifically so that when the water hits it, it doesn't just pool up. So with each piece of styrofoam being angled a certain way, it spins very smoothly and perfectly.
Our generator was built off like basically a magnet and a magnet wire. Magnet wire is basically copper wire with like an enamel coating so that it's magnetic. The idea generally is that when the magnet spins, it creates like a force field per se, and that sends a current off through the magnet wire, which attaches to our light bulb.
And basically to put this all together, we needed something in between because we didn't want the water wheel turning right on the generator because that would create problems. So what we ended up doing is we found a pill bottle and some Lego pieces, and with that we were able to glue them together and tape them together and create a nice little shaft to connect both the water wheel and the generator.
So this was our first attempt. Pretty basic materials, cardboard, scotch tape, and nail. We tested it out and it ended up not working because we were using the wrong type of wire. We were using steel wire and the box was not sturdy enough. It was compressing quite a bit, so it didn't end up working out.
The next thing we decided to try was Lego. Our issue with Lego was that we couldn't get an exact fit. Instead, we went to the 3D printer and designed a case that would allow us to take off the top easily so that we could work with the magnet inside. Our question was whether it would be durable enough, and it was in the end.
After having our 3D printed design, we cut out some plexiglass to use as windows to protect our magnet. It was quite challenging and we did break a lot of pieces trying to drill holes in, but overall we got the box finished, and after that we just had to wrap the box in magnetic wire.
We shaved off the red coating to expose it to the copper wire so it could conduct electricity through the light. Next, we took apart our rechargeable flashlights to examine their generators and salvage their light bulbs.
We attached the light to the generator and tested it. After we knew that our generator would work, we tried attaching the bigger light just to see if we could make that work, and we were able to. It just required a little more energy.
After, we decided to test the voltage. Spinning the magnet with our hand gave us a max voltage of 1.3 volts per second. To simulate the water wheel, we tried a drill, which only gave us a little more, at 1.4 volts per second.
The next step was attaching the water wheel to the generator. For this, we used super glue, super strong, super nice, and once we had it together, we tested it out.
Oh, it is a water wheel.
Water
wheel's getting wet.
Unfortunately, the connecting piece was not strong enough to stay together, so we had to build something a little sturdier to replace it instead.
We created a shaft using a pill bottle and some Lego pieces to connect the water wheel with the magnets. As you see here, we used the sink to spin the water wheel, which spins the magnets. However, this was not enough to light up the light bulb. A little late night stroll allowed us to go to Alex's house where we could use his hose. As you can see, Brian's holding his cranberry juice as I hold the project. Thank you very much for that, Brian.
We got the hose out here.
Mine is 20 weather. Play with water.
Everything turns into ice.
We're Canadians.
It's probably going to be pretty hard to see the light bulb. Where is it? It's my...
It's straight there.
God, I don't get close to this.
Please. I'm not getting wet for nothing.
Okay.
Okay, go check up.
Oh, you gotta...
Yes! Yes!
Do it again, do it again. That one felt amazing. It is windy, it's cold, and it is all ice.
It works!
How did you feel after it worked for the first time?
Oh, I felt like I was reborn almost.
What was your strategy in terms of trying to make a successful machine?
We took a model and we tried to modify it as much as we can just to figure out what was wrong. What do you think about 3D printing something to help your design for your physics project?
It was pretty useful and like effective. The designing part wasn't too hard. I had an issue like getting into Tinkercad, but after I got in there, like making the box itself and like grouping everything together worked out really well.
Will this physics project ever get you a girlfriend?
Next question. So, to explain how the electricity actually works, all metals contain a movable substance called an electrical charge. Even uncharged wires have that electrical charge in them. And metals are they're special because their electrons don't stay connected to metal atoms. They're always flying around, and it's kind of like an electrical liquid inside the wires. All wires are full of this electrical liquid, and the fluid is movable, and this lets metals create an electric charge.
So whenever a circle of wire surrounds a magnetic field, and the magnetic field is constantly changing, a circular pressure called voltage appears. The faster this magnetic field is changing, the larger the voltage. So basically, the faster the magnets are going to turn, the more power we're going to get from our generator. This circular voltage tries to force the movable charges through the wire.
The thing with the generator is that it doesn't just have one circle of wire. You know, there's multiple circles of wire with the magnet moving around it. So just for say that all these wires are connected, that means a small voltage from each little circle will add together. So say we wrap the wire around 100 times, the voltage will be 100 times greater than if we just had one. So if you wrap more wire, you will accumulate more voltage. And that's how a generator works.
So our generator is an AC generator. Every time the magnets flip, it creates a pulse of voltage. When they flip a second time, this creates an opposite pulse to the initial pulse. Each time the magnet makes one complete turn, it creates a forward pulse and a backwards pulse. And if you spin the magnet super fast, it makes an alternating wave.
So the biggest improvement we can make for our generator is the practicality of it. We realize powering a small light bulb with a garden hose isn't the most useful thing in life.
Unless you're hosing your garden at night and you need to read.
So
Anyway.
and maybe. So we have some improvements to fix the efficiency of it.
To improve our generator, we think that a narrower box would work better so that the wires are closer to the magnets.
Also, another thing on that, if you add more wire to the box too, that's going to greatly improve the voltage. So,
As well, stronger magnets would make the force field stronger, which would give more pulses.
Same thing as a lighter, stronger water wheel. I mean, if we can add more pressure to the water wheel, it spins more per minute, and that powers the generator faster.
another big problem is right now the magnets are just on a nail and they're loosely in a hole. So if we could find some way to put some bearings in there, something to make it spin smoother, so you have to put less energy to spin it, that would greatly improve it.
And the last thing is a more compact design so that it's not so big and clunky, where you could just actually use it anywhere, basically.
That's what Physics 12 is for.
See you then, Fogarty.